In this lesson, we'll go through the steps to drawing Lewis structures. We'll follow the steps and use three examples, SO3, NO2-, and IF5. When drawing a Lewis structure, what we are trying to represent is a 2D version of a molecule or an ion that's held together by covalent bonds. And a covalent bond involves the sharing of electrons. These bonds could be polar or not polar, and we'll look at those later. The first thing that you need to do in order to draw a Lewis structure is determine the way in which the atoms will be bonded, and the central atom is usually the least electronegative one, and for the most part you're going to see that it is listed first. So for all of these ones, SO3, NO2-, and IF5, we're organizing them with the central atom and then the atoms surrounding it. And because it's a 2D representation, it doesn't matter how we organize the atoms around the central atom. There's no specific way that they need to look. There's no particular angle they need to be at. The next thing that we need to do is determine the number of electrons that we'll have available to draw our Lewis structure. And it's going to be the valence electrons that are involved in the bonding, so those are the ones that we'll count. So we're going to use the periodic table. In SO3 we have sulfur, and sulfur has 6 valence electrons, and there's 1 sulfur. For oxygen, it also, based on its position on the periodic table, has 6 valence electrons, but we've got 3, so that brings us a total of 18 electrons. When we total these together, we know that in this structure we're going to have 24 electrons. For NO2-, we have nitrogen, so nitrogen has 5 valence electrons, oxygen has 6, and we've got 2. And in this one, we need to pay attention because it's not a molecule, it's an ion. So it has a charge, which means that it's holding an extra electron. So if something has a negative charge, we're going to add the appropriate number of electrons, and if it has a positive charge, we'll remove electrons. So when we're tallying up our electrons here, we're going to add 1. So we've got 12, 17, 18 electrons available. Now for this, you can know that you've done your counting correctly if you've got an even number of electrons, because the examples we'll be working with will all have an even number. For IF5, I has 7 valence electrons, as does fluorine, and we've got 5 fluorine atoms for a total of 35, plus 7 is 42 electrons. So this is a very important step that you'll want to be careful while you're doing this, because a mistake will carry through into your Lewis structure. The next step is to place 2 electrons in each bond. So we draw a stick to join the atoms together, and that represents the bond. And then for this one here, we have 5 fluorines, and again, it doesn't really matter how I draw them around the iodine. The next thing that we're going to do is complete the octets of the atoms attached to the central atom. So in this first one, when we have SO3, we want to look at the atoms attached to the central atom. This oxygen has 2 electrons so far, so in order to have an octet, or a total of 8 electrons, we'll need to place 6 electrons around it in pairs. This oxygen also needs 6. This oxygen also needs 6. So getting to the point of joining the atoms and filling the octets of the outer atoms will eventually be a pretty quick few steps for you. And then we're going to need to do some thinking. So we're just filling. Each one needs 6. And notice it has nothing to do with how many electrons they brought into the structure. These are just the steps that we're following in order to draw an appropriate Lewis structure where we use all the electrons and ensure that all the atoms are stable. The next thing that we're going to do is step 5, and so I'm going to build on these current structures that I have. And what I'm going to do in this step is place any remaining electrons on the central atom in pairs. So I need to refer back to the number of electrons that I had available for the structure. So in SO3 I had 24 electrons available. When I count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So in this particular structure, I've used all the electrons that I need to, so I don't need to do anything for step 5. Another way to count the electrons is to remember that there's 8 around each of the central atoms, so you can do 8 times 2 in this case, or 16. However you count them, it doesn't matter. You just need to make sure that you count all of the electrons, including the electrons in the bonds. So this one has 18 electrons, but I've only used 16 so far, so I place them on the central atom in pairs. In IF5, when I count my total electrons, I've used 40, and I have 42 available. So I need to place that extra pair on the central atom, and I need to put it in a space that's available. So it doesn't matter where I put it, it just needs to be on its own in its own little spot. Now the last step is to ensure that all the atoms are stable. So we've made sure that the outer atoms were stable, but now we need to check in on the central atom. The central atom needs a stable octet, and if it doesn't have an octet, we're going to form double, or if necessary, triple bonds. So we check in on the central atom and count the number of electrons that it has, 2, 4, 6 in this case, and so it still needs 2 more electrons. But from the previous step, we don't have any more electrons to use, so what I need to do is I need to remove a pair from an outer atom and share them instead, creating a double bond. So what that does is it gives sulfur the total of 8 that it needs, but at the same time it didn't have an impact on oxygen, it still has the 8 that it needs. So what we've done is we've created a structure where all of the atoms are stable, and we've used all the electrons and all the atoms available to us. So in NO2-, again, my last step is to check in on the central atom. I have 2, 4, 6. I need another 2, so I'm going to form a double bond by removing a pair from one of my outer atoms. Now, it doesn't actually matter. I could take the electrons from the left-hand side or the right-hand side. It doesn't matter, as long as I ensure that the central atom has 8 electrons. Now, in this last example, it may have had you thinking and wondering if it made sense because it actually has more than 8 around the central atom. So we've got 2, 4, 6, 8, 10, 12 in this case. And you'll see down here there's a little note. The octet rule can actually be broken, and you don't need to worry about when it might be or whether the molecule that you're given actually exists, because the molecules that you're given in this course do exist. And so if the octet rule is broken, so if you come across a molecule that has more than 8 electrons, you need to trust that that is what it should be. And what's happened is the octet has been expanded and there's extra space made to accommodate or stabilize other atoms. The reasons for this lie in that new model of the atom that we've referred to a few times. And they're something called d orbitals, which we don't have the information about right now, but you don't need to worry, because if you follow the steps, then you'll never make any mistakes and you'll have no problems drawing a proper Lewis structure. The one thing that you will need to remember is that boron can be electron deficient. So boron, when you work with it, you'll see that it will have 6 electrons, and that is perfectly fine. So that concludes the lesson in Lewis structures. This is a skill that requires a lot of practice, so make sure that you're doing a lot of exercises to build your confidence and build the speed and accuracy with which you can do this.